Okay, so this conversation is going to focus on tissues. So you have a packet that is entitled just that with tissues. So go ahead and take that one out. That is where you will want to put your notes. Um, the packet as a whole has four different types of tissues. There are four major different types of tissues. We are really going to focus on just two because there is a lot of information that is in each tissue type. And we will get to the muscle tissue and the nervous tissue more in depth when we actually get into those chapters. So majority of our focus is going to be on epithelial and connective tissue. I will touch on muscles and nervous just to introduce it for today, but a majority of that conversation will actually happen later on. So as I mentioned, when we talk about tissue types, there are four different major types of tissue. And when we get to that level of organization of tissues, what we're talking about is that you have a group of different types of cells that are working together to perform a particular task. So one of the key features of that is that it's different types of cells. It's not just a bunch of cells working together, but they are different types of cells that are coming together and they are giving their strengths to each other in order to make sure that a certain job can get carried out within the human body. So when we look at the four major types of tissues, there's epithelial, you have connective tissue, you have muscle tissue, and you have nervous tissue. So epithelial is going to focus largely on linings of different body parts, so the inside of organs, respiratory tract, things like that. You have this protective lining or coating over those surfaces, and that is going to fall mainly to your epithelials. Connective tissue, on the other hand, is really going to be your support type tissues. So when you get into fats, your tendons, your ligaments, things of that nature, that's going to fall into that connective category. Muscle, we have three different types of muscle in the human body. You have your skeletal muscle, your cardiac muscle, and your smooth muscle. And so that belongs to that third one. And then your nervous tissue, which works kind of independently. It is the most differentiated type of tissue that you have in the fact of how it's organized and how it actually works. So looking at those four tissue types, if you go to your second slide in your packet, it shows you the different ways that your tissues can be named. They can be named for the cell shape, and they also can be named for the number of layers that you have. So on the left-hand side of that slide, it's indicating how they are named by the shape of the cells. And on the right-hand side, it is indicating how they are named by layers. So looking at the left-hand side, starting with simple squamous, that is going to indicate, simple indicates that you just have one layer, and squamous indicates that the cell shape is going to be flattened. So typically when we talk about cells, and we just had this in a recent conversation, when you guys think of cells, you think of them as being nice and round. And for the most part, that is very true. The location that you have squamous cells, typically these cells are dying off, and so they don't have that nice round shape. They're starting to lose some of their contents because they're in the process of dying, and because of that, they start to flatten out, and they don't have that nice round shape. So when we talk about squamous, that is the indication. Simple means one layer. Squamous means that the cell is flat, typically indicating that it is in the process of dying. The next one that you have, we're back to simple, simple cuboidal. And if you look at that name, you can see cube within the name, and that is typically the shape. So it's not a perfect cube, but it just indicates that the height and the width are typically pretty close to each other, giving it a near cube-like shape, and so we call those simple cuboidals. The last one that we have are the simple columnars. Simple, still indicating that you just have one layer of cells, but with a columnar, they are going to be much taller, so the height is going to be much greater than the width of the cell. So that is your typical cell shapes. On the other side, you'll see those same shapes with squamous, cuboidal, columnar, but now we change it to stratified. And stratified is going to indicate that you have more than one layer. So these cells are going to be stacked on top of each other for whatever reason. Typically, you would find your simple tissue layers or simple cell types in those places where you need to move things, especially with your simple squamous and your simple cuboidals. By only having one layer of cells, if you need to move something across or through the cells, it's much easier if there's only one layer of cells to have to maneuver through. Stratifieds are usually more in places where you need protection or some product is being produced within the cells so that you have many of them, but usually more indicative of being a protective type tissue if they are stratified and you have several layers of them. The next slide that you guys have talks about the intercellular junctions. And so this is the different ways that cells can be fastened together. If you guys grab onto the skin on your arm and you kind of roll it back and forth, there's some give there. You can push and the skin will move in one direction to a certain extent, and you can pull the other way and it will move that direction as well. And part of that movement is because of the different type of junction or joining that you have between those cell types. In some places you need for there to be movement, in other places you need for it to be very fixed and permanent and how it's put together. And so these are just three of the most common options of how your cells will fix or attach to each other. So the first one talks about a tight junction. And when you look at a tight junction, this is simply going to be, and you can see the cells in the picture that you have there, are going to be fixed together. So every so often, it's not necessarily straight through, but every so often, you're going to have two cells that are fixed or attached to each other and kind of hold an anchor there. But you'll also notice that there's gaps in between those junctions. Like I said, it's not a complete seam. There are openings or pockets between that. And that's just to kind of help secure that, but not have it be completely tight. And the best example I can give you, I told you guys to kind of push around on your skin, you know that there's a little bit of give there. If you've ever wrapped a present or used wrapping paper, when you put that wrapping paper on there, there's no give. If this paper gives, you've actually ripped or torn it, which is what would happen if our skin didn't have the ability to move somewhat. And so just by that spacing within those cell fixtures, you do get a little bit of movement. The second one that you have are the desmosomes. Desmosomes are a little bit different. They are going to form, and it talks about spot welds. What it's actually, the major difference here is that these anchors or these attachments between the cells are actually going to originate on the inside of the cell. And you can see that through the picture. You have like those finger-like projections, and you can see that they move across the cell membrane, and then they actually attach on the outside of the cell. And by having them originate inside and then move through the cell membrane and secure to each other on the outside, this is going to create a much more permanent attachment, a much stronger attachment. So in those places where you have a lot of wear and tear, a lot of pressure or a lot of stress, that particular type of junction between the cells is going to be very important, just to make sure that they hold their location and that they support what they are supposed to. And then the last one is a gap junction. The gap junction, the best example that I can give you for that one, if you've ever been in the Skywalk system downtown, the Skywalks are a series of connections between buildings that normally would not be connected. So instead of having to go outside and walk in the elements from one building to the next, you actually have this walkway that connects two buildings. And that's essentially what you have with the gap junction. You have this area between the two cells that connects them. And the reason that these are so important is because if you have to move a product from one cell to a neighboring cell, if you let it go outside of the cell and kind of have to make its way to the other cell, the problem with that is once it is released from one cell, it might not necessarily make it to its destination. It might get picked up by another molecule. It might get lost along the way. Something else could happen that would interfere with it making it to that second cell. So by having those gap junctions between the cells, you can have a product in cell A, move it through that gap into cell B. It never has to exit either cell. It is always maintained internally between the two cells, and there is never a chance for that molecule, whatever it might possibly be, to get picked up or pulled into something else that's going on around those cells. Remember, you have a lot of different molecules. You have liquid environment around these cells. It's not hard once that cell or once that molecule would leave a cell for it to get pulled into something else, for another molecule to grab onto it, or for it just to kind of float away and never get to where it's supposed to be. So those gap junctions are important just to make sure that those products get exactly where they're intended to be. The next slide is going to start with our conversation on the epithelial tissue and just some of the basic characteristics or traits that you have. As I mentioned already, these are typically going to be your linings. So you're going to find them covering or coating different structures. And it talks about hollow organs. So the inside of your stomach, the inside of your intestinal tract, those places that have an open space would be the most common places where you would find epithelial tissue. It's a very thin tissue. Usually you can see through it. If you've ever pulled skin away from the meat, so if you've ever had like a piece of chicken and you pull the skin off, you'll notice that there is that white kind of connective tissue between the two, or connecting the two. That would be an example of epithelial. So with your epithelial tissues, because they are going to line the inside of an open cavity, you are going to have some cells that are going to face that open area. So there's two sides to your cells. You have what is known as the apical side, and then you also have what is known as the basement membrane. So the apical side of the cell is going to be the side that faces the open area. The basement membrane is going to be the side of the cell that is actually fixed or attached to the structure or the organ. So if you think about your carpet that you have in your house, the side of the carpet that you can see and that you would walk on and you could touch with your feet, that's the apical side. That is the side of the carpet that is open to the area within your room. You have the underside of the carpet, which is going to rest on the concrete or whatever else you might have, and that is going to be the basement membrane. That is what is fixed and secured to the underlying structure. So your cells have the same setup, with an apical side facing the open and the basement membrane, which is attached or secured to the structure itself. A lot of times when we talk about our epithelial tissue, it is avascular, meaning that it lacks blood vessels, and that's going to contribute to the clear nature, the thinness of it. When your blood supply is delivered to your cells, you have to have a blood vessel within 2 millimeters of any living tissue or any living cell. And so with these being avascular and also being extremely thin, they can still be in close enough proximity to a blood vessel to get all of the oxygen and all of the nutrition and everything that they would need without having their own direct blood supply. So they can, through the process of diffusion, they would be able to get all of those materials and nutrients that they need. The next few slides that we have are going to kind of give you examples of the different types of epithelial. I put two pictures of each category. The one on the left is a computer generated one. The one on the right is going to be an actual picture that was taken with a microscope. So those would be actual cells that from the body that had been stained. So the simple squamous, you can see that you have just one layer of cells there, and with the cells, you'll notice that round structure inside, so it's showing you where the nucleus is. And then you can see the flat nature of the cell itself. And if you go over to the simple cuboidals, again, you can see that you have those round tube-like structures. You have one layer of those cube-shaped cells lining just the inside of that tube. You can see the dots, which indicate the nucleus that you have within each one of those cells. So one of the key features that you can kind of use in identifying the tissue type that you're looking at is with epithelial tissue. When you transition from epithelial, and you'll notice that sitting underneath of it, you have connective tissue that's identified in that picture, in both pictures actually. There's an actual color change. So your epithelial tissue is going to have a particular color, and as you transition from epithelial and you start to get into the connective tissue, you will see a color change happen. And we'll talk more about this as we get into the tissues and we practice with them a little bit. But just kind of have that in the back of your mind. When you're trying to distinguish the tissues, use that color change as your indication of where that line might be. The next slide that you have talks about epithelial tissue, and now we're seeing simple columnars and we're seeing something called pseudostratified. So with your simple columnars, one layer of those column-shaped cells, so they're going to be taller than they are wide. Couple of indicators on your columnars. Almost all of your columnar cells are going to have cilia. So if you look at the surface of both of those cells for both the simple as well as the pseudostratified, you're going to notice that there is cilia lining the top of them. So you have a very distinct shape. You have their tall, narrow shape and structure. But then if you see those cilia, immediately jump to columnar, that you are looking at some type of columnar epithelial tissue. Now, with the simple columnars on the left, one thing that I want to point out is if you look at the nucleus, it's not perfect, but if you look at the location of the nuclei in the cells, you'll notice that they're pretty close, or they're more to the basement membrane side than they are to the apical side of the cell. So remember, the apical side is going to be open, or facing that open area. And then you have the connective tissue, which is identified on the picture for you. You'll notice that's the basement membrane side, but you'll notice that those nuclei are kind of gravitating more towards the basement. And that's because that's where they're going to get the most protection. Okay? They're going to be buffered on the backside with that connective tissue being there. So by being closer to that side, they get an added level of protection. Now, pseudostratified, pseudo indicates fake. So it's a fake stratified columnar. This particular type of epithelial tissue looks like it has layers to it. It's actually only one layer of cells. So that's where the pseudo comes in from. It gives the false appearance of having layers when it doesn't. And what kind of helps with that false appearance is in this one, when you look at it, you'll notice that the nuclei are at different layers. Some of them are a little bit higher up, some of them are closer to that basement membrane, but they're not as much aligned as they are in the simple columnars. They start to bounce around and move through the cells a little bit. But if you were to look at each one of those cells and track it, each individual cell is going to attach directly to the basement membrane. And I know with a small picture like this, it's kind of hard to see, but because each cell is directly connected to the basement membrane on its own, that is still going to be just a single layer of cells that you have present there. Again, I realize for some of you, this is probably the first time ever looking at tissues. So if this is new to you, don't worry, we will practice. The next one that we have for the epithelial tissue is going to be the stratified squamous as well as the stratified cuboidal. So here you have several layers of cells that are going to be involved on the left-hand side, stratified squamous. This would be an example. Best example is the layer of skin that you guys can see and touch is a stratified squamous layer. So the closer you get to the surface, you'll notice that those cells are the flattest. Those are the ones that you guys are getting ready to slough off. So skin cells that are on the surface are constantly flaking off and floating off into the air. And so because they are dead at that point, they have lost most of their cytoplasm, which accounts for the flatness. As you get closer to the basement membrane, you'll notice that they start to take on a little bit more shape and start to look more like a round typical cell. And then here's where you can really pick up on that color change. So you see all of those stratified squamous cells stacked on top of each other, and then you have that very dark line, and that is your basement membrane. That indicates that you are transitioning from epithelial cells. So you hit that dark line, you just hit the basement membrane where those cells are attached, and below that dark line, now you are into a different tissue type, which is connective tissue. So that color change is something that you can really use to help identify where one layer of tissue is and where the next one begins. And then you have the stratified cuboidal. So we have two layers of cube-shaped cells. And again, you'll see that ring, and you can see how it's, to me, it's easier to see on the left-hand picture, the computer-generated one, but you can see where those cells are stacked on top of each other. You can see the nuclei in the cells. I kind of have on yours, because it's gray, they have a darker appearance. If you are looking at it in your textbook, they are stained blue, and so you can see where those nuclei are, but that would be an example of having layered cube-shaped cells. The next one that you have the stratified columnar. We've already talked about the columnar, presence of the cilia. You know, because it's stratified, you have more than one layer of cells involved. Again, you can see the color change when you're looking at the picture. You can see the darkness of the epithelial ones, and then you can see the lighter area underneath where you have transitioned into the connective tissue. On the right-hand side, you have what are called transitional cells, and this is one we haven't talked about yet. Transitional cells are going to be a combination of cuboidal, so the cube ones, and the columnar, the tall, skinny ones. And you find this in places where you need to have some stretch. And what happens is they're set up so you have alternating cuboidal, cube-shaped cells, and alternating columnar cells, the tall, narrow ones. And so they alternate through the tissue. And what happens is when the tissue is not being used and it's constricted, they all hold their shape. But when you need to stretch that particular type of tissue, then what happens is the columnars go from being tall and narrow, and they actually stretch, and now they become flat and long. And that allows for different body parts to expand when they need to. Best example I can give you here is your bladder. You go to the bathroom, you void and empty your bladder, it's going to constrict down, and those cells are going to be cuboidal columnar in their normal shapes. As the bladder takes on urine, those cells are going to need to start to stretch and expand to accommodate that building liquid inside the bladder. And so those tall, narrow columnars are going to start to stretch out so that the bladder can expand until you are able to void that urine again. So transitional cells are going to be in those locations where you need expansion of some sort. The next ones that we have are the connective tissues. Now, the connective tissue is the most abundant type. So you have the most variety of different types of tissues. And I want to clarify from what I mentioned earlier. Your nervous is most unique in how it's designed. Your connective tissue is going to give you the greatest number or different types of connective tissue. So we see everything from fat and adipose tissue to tendons and ligaments to your blood. And for some people to make that connection, how do we go from some of the most rigid things that we have in the human body to something that most would classify as a liquid? And the reason that we have such a wide variety is because it goes back to stem cells. So during embryological development, the same cells that give rise to your tendons and ligaments are ultimately going to give rise to your blood cells as well. So they start very early on with the same type of development, and then they hit that point where they get their specialized instructions, and a certain group will go off and become tendons and ligaments, and then you have a different group which is going to become your blood. But because they originate from the same cell types very early on, they are all classified as connective tissue. So they do a variety of things. They will support the body, give structure. They also will pack into open spaces, so where you have joints and kind of need filler and things like that so that you don't have gaps. It's not uncommon to have connective tissue packed in there to help with that. So they do a wide variety of jobs within the body. I want you guys to go ahead and find the slide that starts with your loose connective and adipose tissue. So when we get into our connective tissues, we do have some very unique ones. Number one is the adipose. Adipose look blank. When you see them on a slide, all you can see is the outline. You will not really see a nucleus inside of them. It's just going to be an outline and then look completely hollow and empty inside. As soon as you see that, you know that you are looking at adipose tissue. For a variety of your other connective tissues, what you are looking for is fibers. You will not find fiber in any of your epithelials. Okay, so that's a distinguishing characteristic between the two. Epithelials, you will see a distinct color change when you transition from one tissue type to another. You will see a hollow open space somewhere in the picture, typically. And you will not see any thread-like hair-looking things that are fibers. As soon as you see a fiber in the slide or image that you are looking at, you immediately know that you are looking at some type of connective tissue. So you have the loose connective tissue there on the left. You can see those threads and those fibers running through. So immediately, as soon as you see those, you are going to know that you are looking at connective tissue. In the loose connective tissue, you'll notice that the fibers really don't have any sort of arrangement. They're just sort of sporadic throughout the slide. And that appearance will change as we look at some of the other ones. So if you go to the next slide looking at reticular connective tissue, again, you see the fibers, but this time with the fibers, it looks like somebody kind of crumpled them up. So in loose connective, the fibers are arranged sporadically, but the fibers themselves are straight. With reticular connective tissue, it looks like somebody took the fibers, almost like you take a piece of paper and crumple it up. Those fibers are crumples. They have wrinkles in them. And that is your clue that you are looking at reticular connective tissue. The next one that you have is dense connective tissue. And dense connective tissue has a very distinct feature because this time your fibers look like waves. So if the fibers are straight in appearance, that's loose connective. If they are crumpled and wrinkled in appearance, that is going to be reticular. And if they are going to be in a wave-like fashion, that is indicating that you are looking at dense connective tissue. The next one that I want you guys to take a look at has both your elastic connective tissue as well as your bone tissue. Now, elastic, the fibers that you have here are very thick and dense. So the other ones look like hair strands. With elastic connective tissue, these are found in places like your ears where you have a lot of flexibility. And that is going to, the appearance of those fibers, like I said, very thick in nature. They're not thin, very, very dense. And that is one of your telltale signs that it is elastic connective tissue. Bone is usually a little bit easier. You don't have fibers or threads running through them, but you have almost a target-like appearance. So in your bone tissue, the giveaway sign that it's bone tissue is that you have these rings, and then you have concentric rings within it, giving that appearance of what you guys would think of as a target as having. The very center of the ring is usually dense and darker in color, which again is an easy feature that you can use to identify that particular tissue type. The next one that I want you guys to take a look at, find your slide that indicates blood. So this is another type of connective tissue. When you look at your blood slides, you will see, for the most part, red blood cells, and they will have a pinkish to red tint to them. Every once in a great while, you will find a white blood cell, which is going to be larger than the red blood cells, and it usually is going to appear purple. So when you see nice round cells, pink and red for the most part, that is going to be your indication that you are looking at a blood slide. If you happen to see a large purple cell in there, that is just a white blood cell that made its way into the image. For your muscle tissue, I'm not going to spend a whole heck of a lot of time on these right now. I just want you guys to know that you have 3 different types of muscle tissue. Skeletal indicates that it attaches to bone. Smooth is going to be involved with your internal organs. And then cardiac, the only place you find that is within your heart muscle. So right now you just need to know that there's 3 different types of muscle tissue. We will get into all of their features later on. And then the last one, the nervous tissue. The big thing that I want to point out here is the design feature, and I've hit on it a couple of times already. But with our cells, you guys think of cells as being nice and round. With the nerve cell, because of its job, it has to relay information very, very quickly through the body. It can't have that nice round structure. It's very long, it's very narrow. It has these finger-like extensions coming off of it so that it can send information as quickly as possible. So 4 different types of tissue: epithelial, connective, muscle, and nervous. A lot of information on your epithelials and your connectives, with not as much on our muscles and nervous right now because that will be coming up later. So for right now, that kind of concludes our conversation on tissue types, and make sure that you check Blackboard for your assignment.